What's up guys, in today's video I'm going to teach you and I'm going to show you how to create a stack in C. You are going to see that it's something very simple and yeah, let's get to that. First of all, let me explain you what is a stack. A stack is a data structure that follows the LIFO method, which is the last in, first out. So what does this mean? So for example, let's say that we have this thing here and this is the stack. Is empty. So whenever we introduce something, let's say that we push is something very important, a 1, okay, we push a 1, the 1 comes here, and then let's say we also push another number, which is the 2, and okay, that's a 2, so the 2 comes here, and then finally let's say that we push another number, which is a 3, so this 3 comes here. So since we are following the LIFO method, this means that whenever we want to pop is the other action in which you take the element, you take the last one, last in, first out. The last one that came in is the first one to come out. So the last one was the 3. So what we do is that we remove the 3 and we take it out. So if we pop again, we take the 2, and yeah, if we pop it again, we take the 1. So with this you understand what is a stack. It's something very simple, and now we have to code this in C. So the things that you have to take into account is that we need to implement these two actions. The push, which pushes elements into the stack at the end, and the pop, which takes the last element introduced. So let's get to this. We are going to go to the Visual Studio Code, and here I already have a makefile to compile and all that, but this is for later. So the first thing that we are going to do is to create a .h file in which we are going to define the primitives, the functions that we are going to create. So we are going to call this stack.h, and here we have to include several libraries such as the standard library, stdlib, and here we also need to include the standard input-output because we are going to print the stack later. So standard input-output. And yeah, now we are going to rename the structure. We haven't defined the structure yet, but the structure is going to be something like this. It's going to have this stack, but the name that it's going to have is this, stack with the capital letter. So which are the functions that we are going to implement? First one, we need a function to create in memory that stack. So for that, we are going to create a function that returns a pointer, a stack pointer, and this one is going to be called stack_any. The next one is a function to push that action that we talked about before. So we are going to call this push, and we need to receive a stack, and also we need to receive the value of the stack. So this stack is just going to contain integer values, so we are going to push that. So what is the next thing that we need to also do? We need to pop, and since we have in the stack integer values, we are going to pop an integer value. That's why here I'm putting int, because this is what the function returns. So if we continue, now we need some other primitives such as stack destroy. We need to receive the stack to be destroyed, and also we are going to print the stack. So here we are going to put stack print, and we need to send the stack that we want to print. So we have defined now the primitives and the actions that we want to do with the stack. So now it is time to implement this. So we are going to create a file called stack.c, and here inside this file, the first thing that we need to do is to include this .h file. So we are going to do include stack.h, and now here we are going to declare this structure. So we are going to say that the structure struct stack is going to be equal to, and this is important, as I said here in the paint, the stack is basically just an array of elements. So here what we need is a pointer to that array of elements. So here I can say, okay, int, since we are going to store int elements, we are going to have an int pointer, which is going to point to a variable called items. So this is going to be the array in which we are going to store all the elements. So next thing that we need to do is to store the number of elements that we have. This is going to be really very useful in order to pop elements, to insert elements, etc. So we are going to put here short num items. And yeah, by the way, I always forget to say this, but you have this code in GitHub. So if you come here, you put GitHub, you come to trading bot, you put, you come to tutorials, here on C, here you have all the code that I'm going to implement. So you have the stack C, the stack H, and the main.c. So I always forget to tell you that, but yeah. So if we continue, now that we have the structure, we need to define the functions. And the first one that we were going to define was the initialization of the stack, the one that is going to create the memory. So we are going to put here stack.s. Well, this is this variable called s, in which we are going to store the stack. So this is a null point. Well, this is a pointer which is initialized to null at the beginning, but now we also need to initialize this by reserving memory. So here I'm going to say that, hey, I'm going to cast this to a malloc point, well, to a stack pointer, and here I'm going to use malloc. The thing about malloc is that it uses a void pointer, and we need to cast it to a stack pointer. So now we need to set here the size of the stack, which is just the size of the stack without any pointer or anything. So now that we have this, we can check if the allocation was done correctly. If it's not done correctly, we are going to return null. So now that we have this, the next thing that we need to do is to just simply initialize the elements. So here, what I'm going to do is that sItems is going to be equal to null, because at the beginning it's not going to have any elements, and the number of items that we have is 0 because we don't have anything. So now we return the s, and the next thing that we need to do now is to push elements. So here this function doesn't return anything, but we have to call it stack push. Well, not a stack push, let's call it just push. I think I called that, yeah, push. So we call this push, and we receive the stack, which is this one, and now we receive the value which we want to push. So now inside here we can do several things. So now what we are going to do is that we are going to initialize this array. So for that we are going to use the realloc function, which receives the size of the array in which you want to initialize it. So for example, if I say sItems is equal to realloc, and here this is also a null void pointer here, the only thing that I have to send is, okay, the actual pointers that we are going to use as items, and now the new size of the array. So here we are going to say that, okay, we want the number of items, this is very useful, plus 1, because now we have 0, so we need, if we are going to push an element, we need to add 1. So one element by the size, okay, size of int. So now we are going to create enough space for one int. Now let's say that we have a stack with one element and we need to push another one. So now the thing that we will do here is that we will allocate enough memory for 2 integers. So that's how we do it, and it's very useful. So here we are going to check now if the items are equal to null. We are going to return, and yeah, this is in the case that it happened something strange with the operating system, but yeah. So the next thing that we need to do is to actually set the value. So here we are going to access the element that we have here, and since this value has the index of the last element, we are going to say that here we are going to put the last element, the value that we receive. And why am I doing this? Because look, let's say that we have a stack of 0 elements. We push a new one, and here we have a space for one element, but this variable is still 0. So we are trying to access the element 0 of the array, and this is totally fine because if you remember, here the arrays are like this. So this would be the element 0, this would be the element 1, and this would be the element 2. So having this to 0 is totally fine. Now, what we have to do is that we need to increase this value because now we have one element. So whenever we want to push another one, now we would access to the element 1. So we would access here and add it here. Okay, so now we have the push function, and now it comes the tricky part, which is the pop function. So here we are going to use, well, not void, we have to return an integer. We are going to call the pop function, and we receive just an stack. So now we need to check something. So let's say that the stack is empty. So how do we check if the stack is empty? We just need to check this variable that we have here. So here, what we need to put is, if the number of items is 0, it means that it's empty. And for making this simpler, we are going to say that we are going to return -1. So yeah, this is very, very, very useful. But what if the stack is not empty? Where is the last element? So as we said before, since now this number is increased, like let's imagine about, well, let's think about the previous example in which we just have one element. We have the element 1. So now that variable, the num items, is equal to 1. So in order to access to this value, we need to subtract one value here. So we have 0 and we are accessing this one. And the same happens if we have a 2. Well, if we have 2 elements. So for example, if we need to pop this element, what we need to do is to subtract one value to this one, because this is the actual value if we have 2 elements. So we are accessing here. So for that, then the only thing that we need to do is to say, okay, the last element is equal to the items, and now we are going to access to that element that we set. So for that, we put num items -1. So now we have here in this variable the last element. But now, since we are going to pop, imagine that we want to pop this element, we need to delete it. We need to come here and delete this element. So how are we going to do this? It is very, very, very simple. So first of all, we are going to use again the realloc function, but the realloc function has a problem. Let's say that we have a number of items, and let's say that if we subtract one element to the number of items, this is bigger than 0. Here, the realloc function doesn't have any issue. But what if we subtract one element and we call the realloc function with that? Let's do that here. So if we, for example, call realloc in the same way we did here, but with one element -1, in this case, we are sending here a 0. So this is a real issue. This is going to give you an error. So basically what you are trying to do is just simply freeing the memory here, like you want to not have this items array. So for that, instead of calling here realloc, we are going to free the array. And we are going to say that as items is equal to null. But yeah, now that is in the case that we have just this element, we are popping this element, and now the array is empty. So we don't really need to be storing the array. So we are going to free everything. So in case we have more than one element, so for example, we have this, let me put here a 4. We have this 4 and we want to pop it. What we need to do is, okay, we are removing this 4th element, and now we have a stack of 3 elements. So we need to be efficient and we need just 3 elements. We don't need a space for 4 elements in a stack of 3 elements. So we just need 3 elements. Well, a space enough for 3 elements. So what we are going to do here is that we are going to say that the array items is going to be equal, let's do the cast here, to what realloc returns whenever we use here the pointer, and now we have to set the size, and now we need a new size. So what is this size? We are going to say that it is the number of items minus 1, and here we are going to put size of int. So now it can happen that this returns an error, and we say that here if this is equal to null, we are going to return minus 1. So that's how we do this, that's how we do the pop. So now we are being efficient with the memory. So again, if we have 4 elements and we delete 1 element, we don't need a space for 4 elements, we just need a space for 3 elements. And that's what we are doing here. So we have to also, don't forget, to decrease the number of items here. And also we don't have to forget to, my god, I'm going to put it, return the last element. So now we have done all the difficult part, because now we just need to destroy the stack, which is something very simple. So here what we are going to do is that we are going to call here stack destroy, and we receive the stack pointer, and here first of all we are going to free the array. And this is important, I forgot here, I have to say that if this is not null, because if it is null, it means that we already have this freed and we would been trying to free twice, and this would return an error. So here we are going to say free as items, because imagine that we have a stack of 0 elements. We actually don't have this item, it's already freed, so we have to check this here. And then the other thing that we have to do is to actually free this stack, and it is as this. Very, very simple. So now the next thing that we are going to do is to print this stack. So we are going to use a stack print, and here we are going to put this, and it is just simply a for loop iterating over the array elements. So for this we are going to put int I equal to 0, I less than the number of items. We are going to increase I, and simply we are just going to print f the number. So here we are going to put this, and we are going to print the value, and finally let's print a new line, so we are okay and it looks nice. So okay, we have finished doing this stack, but now let's create a main function, a main file actually, in which we are going to check if this is okay. So let's put here int main, we are going to return at the end 0. We also need to include this, not the stub, we need to include the stack.h file in which we have all these functions. And okay, no errors. And now we need to do the following. We need to create a stack, calling a stack init. We need to also destroy the stack at the end, so we are going to call stack destroy. Oh wow, stack destroy here with the stack, and we are going to push and pop some elements. So for example, we are going to say stack, well, no stack, we are going to push into the stack a1. So let me copy this several times, 2, 3, 4, and in all these, oh wow, not here. In all these cases, I also want to stack print all the elements of the stack. So we see what is happening. Let me print f a new line here, so we separate the push from the pop. And now what we are going to do is that we are going to pop elements. So for that, we are going to do the following. So we are going to pop, and we need to pop this element. And the next thing that we need to do is to, okay, let's say that we have here a value. Well, let's print f this. So let's put here print f, and let's say pop, and we are popping this value. Let's print later the stack, and here we are going to put this. So this should be fine. Okay, this is fine. And then we are going to do this several times, 4 times. And finally, we are going to also stack print all that. Oh, not this. So we are going to stack print all this. And yeah, I think we are ready to go. So what we can do is to check this makefile. As I said before, it's very simple. So this removes the executable, this creates the executable, and this executes. So if we put here make, it should do everything, and we have some warnings. So okay, here in the real log I was wrong and I did a cast that I didn't have to do. So here this real log is stuck because this is of the size of int. So this is true. We need to put here int instead of a stack. I forgot. And let's clear. Later we will check that. And okay, so as you can see here, this is working very fine because these are the 4 first pushes. And if we check here, first of all, what we are doing is that we are pushing a 1, then a 2, then a 3, and then a 4. And if we check the stack, it is happening what we want. So we are pushing a 1, we are pushing a 2, and we have now 1 and 2, we have now 1, 2, 3, and we have now 1, 2, 3, 4. But now let's say that we want to pop, and as we said, we need to pop the last element that we pushed. So as you can see here, we are popping, and whenever we call the pop function, we are receiving the value that we pop here. So the value that we pop in this case is the 4, which is the last element. Here it is the 3, which is now the last element here. Now the 2, which is the last element here. And finally the 1, which is the last element here. And we have a empty stack. So another cool thing that we can do is to check all this again. Because now the stack is empty, but we can check if this worked again. So what we can do here is that we are going to call we are going to clear. Let's make this a little bit smaller and let's call make, and you see that it works perfectly fine. So if the stack gets empty, it's okay if we try now to fill it with elements again. So there's not an issue with that. And now another thing that we can do is that we can check Valgrind. We can check if we have done the freeze and the allocs okay, like in a right way. So for that we are going to put Valgrind minus leak minus check equal full, and here x. So you can see that we have done 16 allocations, 16 freeze, and there is not any issue. Well, there aren't issues with this program. So I hope you enjoyed this video. I hope you understood how to create a stack, and this stack is going to be very useful if we want to learn how to do breadth first search. And yeah, no, or depth, I don't remember, one of those. So yeah, that I will speak about that in another video. But yeah, I hope you enjoyed this video. I hope you understood how to create a stack, and if so, give it a like, share, subscribe, and see you in the next one.